So in last lecture, we were discussing this example r is equals to a into 1 plus sine theta. So we have discussed there about symmetry, that this curve is symmetrical about y-axis because if we replace theta by pi minus theta, equation remains unchanged. So by third rule, uh, we got this symmetry. Rule 2, we have seen it passes through pole because for theta equals to 3 pi by 2, the value of r is 0, as 3 pi by 2 sine 3 pi by 2 is minus 1. So curve passes through pole. Since curve passes through pole, we'll find out the tangent at pole. So substitute r is equals to 0 in equation 1. So we have got theta equals to sine inverse 1. As we know, sine inverse x is a multi-valued function, so we'll get multiple values of theta. So minus sine inverse minus 1 is 3 pi by 2, as well as 7 pi by 2, 11 pi by 2, and so on. So 3 pi by 2, 7 pi by 2, 11 pi by 2, and so on. All are tangents at origin or tangents at pole. Right? Now we'll see rule 3. So rule 3. So here we prepare a table of values of r for different values of theta. So theta r. Now here to prepare this table, you are free to select values of theta randomly. So for our convenience, we'll select 0, theta equals to 0, then middle value pi by 4. You can take any other value here in this first quadrant, but for betterment, we'll select this middle value. So 0, pi by 4, pi by 2, 3 pi by 4, then pi, 5 pi by 4, 3 pi by 2, 7 pi by 4, and last 2 pi. So see the value of r for theta equals to 0. So theta 0, sine 0 is 0. So r is a. So theta equals to pi by 4. So sine pi by 4 is 1 by root 2. So it is a into 1 plus 1 by root 2. Then theta equals to 90. Sine 90 is 1. So it is 1 plus 1, 2a. So r is 2a here. So theta equals to 3 pi by 4. So sine 3 pi by 4 is again 1 by root 2. So you can check this value. Right? So it is a into 1 plus 1 by root 2. So for pi, sine pi is 0. So it is a. So sine 5 pi by 4. So see, sine 5 pi by 4. So you can find out this value. Sine 5 pi by 4 is minus 1 by root 2. You can check it later on. So it is a into 1 minus 1 by root 2. So 3 pi by 2, it is 0. 7 pi by 4 is again a into 1 minus 1 by root 2. Sine 7 pi by 4 is minus 1 by root 2 again. And sine 2 pi is 0. So r is a there. Okay, so with these values of r for different theta, we'll trace the curve. So before that, we'll check the region of absence. A region of absence of curve. So here, since r is real always for any value of theta. Since equation is r is equals to a into 1 plus sine theta, so for any value of theta, this r will be real. It will never be imaginary. Right? So this r is always real for any value of theta. Therefore, curve exists in every sector. Okay, sectors, I told you, it is the space or region between two lines, theta equals to alpha and theta equals to beta, right? So curve exists in every sector. So see the curve. So theta 0, theta pi by 2, theta equals to pi, theta equals to 3 pi by 2. So we have selected again middle values, so we'll draw those lines. Theta equals to 3 pi by 4, theta equals to 5 pi by 4, theta equals to 7 pi by 4. So this is pole. Now we'll draw this point, we'll represent this point on this x or y plane here. So for 0, r is a. So when theta is 0, r is a. So this is the point a comma 0. When theta is pi by 4, r is a into 1 plus 1 by root 2. So it is a little bit greater than a. So it will be here somewhere. Then for theta equals to pi by 2, it is 2a. So it will be here somewhere. This is 2a comma pi by 2. Then since it is symmetrical about y-axis, so we'll get the similar point here. See, for 3 pi by 2, it is a into 1 plus 1 by root 2. So it will be here somewhere. Then for theta equals to pi, value is a. So it is here somewhere. This is a comma pi. For theta equals to pi by 4, it is a into 1 minus 1 by root 2. So it is a little bit less than a. So it will be here somewhere. And since it is symmetrical about y-axis, so same point will be here. Or you can check it. For 7 pi by 4, it is same point, a into 1 minus 1 by root 2. Now we'll draw the curve. Okay, it passes through pole as well as it passes through this point. Now the region of absence, we have seen it exists in every sector. Okay, so see, tangent at pole, we have seen tangent at pole is 3 pi by 2, 7 pi by 2 and so on. So 3 pi by 2. So what's a 7 pi by 2? 7 pi by 2 represents again same line, 3 pi by 2. If you rotate it through 2 pi in anti-clockwise direction, you'll get the same line, 3 pi by 2. So this 3 pi by 2, again this line is represented by 7 pi by 2, 11 pi by 2 and so on. Right? So this is the only line which is tangent to the pole. So since it passes through pole, this line is tangent to pole, so nature of curve will be definitely like this, and it passes through this point, so the curve will be like this. And since it's symmetrical about y-axis, so same curve will be here like this. So this is the rough sketch of r equals to a into 1 plus sine theta. Okay, a rough nature of the curve for the equation r is equals to a into 1 plus sine theta. Okay, so this is the simple way. Now we'll discuss two more examples so that you'll get clear idea about this. So second example, r equals to a into 1 plus 2 cos theta. So first rule is about symmetry. So replace theta by minus theta. Here cos minus theta is cos theta, so equation remains unchanged. Therefore curve is symmetrical about the line theta equals to 0, or you can say x-axis. Right? If I replace r by minus r, equation will change, so there is no symmetry of two pole. If I replace r by minus r, theta by minus theta simultaneously, still equation is changing, so there is no symmetry about y-axis, but we have equivalent rule to get the same symmetry, that replace theta by pi minus theta. So if I replace theta by pi minus theta, I'll get cos pi minus theta, pi as it is cos theta. So pi minus theta means second quadrant where cosine is negative, right? So the equation will change here. Therefore it is not symmetrical about y-axis. So there is symmetry only about initial line, or you can say about x-axis. Okay. So rule 2, pole or origin. So here r is 0 for theta equals to 2 pi by 3. So you can check this value, cos 2 pi by 3, cos 120 is minus half. So 2 get cancelled, so we'll get 1 minus 1, 0. So r is 0 for theta equals to 2 pi by 3, and therefore curve pass through pole. Okay. Now we'll find out tangent at pole. So tangent at pole will be 2 pi by 3 again. So we'll see, put r equals to 0 in the equation. So you'll get a into 1 plus 2 cos theta equals to 0. So this implies 2 cos theta equals to minus 1. Therefore cos theta equals to minus 1 by 2. So theta equals to, so we'll get theta equals to cos inverse minus half, which is 2 pi by 3. Is it 2 pi by 3 only? No. So one more theta will get, that is 4 pi by 3. So you can check these values, 4 pi by 3. So we'll get minus half. Cos 4 pi by 3 is minus half. Okay. So equation of a tangent to the pole are 2 pi by theta equals to 2 pi by 3 and 4 pi by 3. So these are the tangents to the pole. So rule 3, here we'll prepare a table. In this rule, prepare a table of values of r for different values of theta. So as I said, you can select this values of theta randomly. Okay. So here we'll select theta equals to 0. Right. See, we'll come to this two-dimensional space. So it will be easy to select the values of theta from this. So theta equals to 0. Theta equals to pi by 2. Theta equals to pi. Theta equals to 3 pi by 2. So in between 0 to pi by 2, we'll select pi by 4. So in between pi by 2 to pi, we have a tangent to the pole, which is theta equals to 2 pi by 3. So we'll draw that line. Theta equals to 2 pi by 3. So we'll select this. Now in this quadrant between pi to 3 pi by 2, again we have tangent to the pole, that's a theta equals to 4 pi by 3. So in between 3 pi by 2 to 0, we'll select randomly. So for betterment, we'll select this middle value. So it is 7 pi by 4. Okay. Now we'll find out the value of r for these theta. So 0, pi by 4, pi by 2, then 2 pi by 3, then pi. Now we'll find out the values of r for these values of theta. Okay, so r is a into 1 plus 2 cos theta. So cos 0 is 1. So for theta equals to 0, value of r is 3a. So for theta equals to pi by 4, so cos pi by 4 is 1 by root 2. So 2 by root 2 means root 2. So it is a into 1 plus root 2. So pi by 2, so cos 90 is 0. Cos 90 0, so r is a there. So for 2 pi by 3, it is 0. We have seen it. So pi, cos pi is minus 1. So it is r is minus a for theta equals to pi. 4 pi by 3, it is 0 since it is tangent. So 3 pi by 2, again it's a because cos 3 pi by 2 is 0. So for 7 pi by 4, so you can check cos 7 pi by 4 is again 1 by root 2. Therefore, value of r is a into 1 plus root 2. And for 2 pi, it is 3a. So after this table, now we'll show these points on the coordinate axis and on the lines. So see, for theta equals to 0, your r is 3a that we have seen. So 3a represented somewhere here. So it is 3a comma 0. Okay. So for theta equals to pi by 4,